Welcome to Climate Reflections, the SRM 360 podcast, where we discuss sunlight reflection methods, ideas to reduce the impacts of climate change by reflecting sunlight away from the Earth, and where we try to understand the contribution they might make to the fight against climate change. I'm your host, Dr. Pete Irvin, and this is the first of our themed episodes. In this episode, we hear from scientists around the world studying sunlight reflection methods, or SRM. What got them started in the first place? Why are they studying SRM? And what do they think about it? But first, some context. The climate is changing. The burning of fossil fuels is leading to the buildup of heat-trapping greenhouse gases in the atmosphere. This is causing the Earth to warm and familiar climate patterns to change. From intensifying extremes of heat and drought which impact people and crops, to the melting of mountain glaciers which help to keep rivers running year-round, and to marine heat waves which bleach and kill coral reefs. These changes to our climate are having profound impacts on people and ecosystems. Like everyone else, experts who study SRM are exposed to these climate risks. They also spend their days immersed in data that make these risks all too real.
My name is Alfonso Fernandez. I'm a full professor of geography at Universidad de Concepción in Chile. Chile is likely one of the most sensitive countries in terms of mountain hydrology for global warming. The shrinkage of glaciers and seasonal snow is an issue here. Nearly 80% of glaciers in South America are in Chile. So when you lose them, you're losing most of the cryosphere of the southern hemisphere outside Antarctica.
My name is Maria Belaya. I'm assistant professor at the Department of Computational Data Sciences at George Mason University in the US. I'm an environmental economist interested in climate policy, and I'm looking at the whole universe of instruments, mitigation, adaptation, carbon removal, and soil geoengineering. Climate change is a global problem, and none of the regions of the world will be left untouched and unaffected. As for myself, there are three places in the world that I call home. It's Petrozavodsk, my hometown in Russia. It's Hamburg, Germany, and Northern Virginia in the US. Out of those, Petrozavodsk is the furthest north, so 61 degrees north, in fact. And the common myth is that northern countries would benefit from climate change, but that's not necessarily true. So Russia, 65% of Russia is actually covered by permafrost. And so the consequences for infrastructure from melting permafrost can be tremendous. In addition, permafrost would release carbon dioxide, methane, as these microbes in the soil would feast on the defrosting biomass.
My name is Panampay Narenpitak, or Ping Ping. I work at the National Science and Technology Development Agency under the National Electronics and Computer Technology Center, or NECTEC, in Thailand. And my country is vulnerable to climate change in a few ways. First of all, the temperature is increasing a lot, and people have felt it, especially the past 2 summers. The second part is precipitation. Changes in precipitation amount and patterns will affect agriculture system and the livelihood of the people. Warmer climate will lead to sea ice melting, and that changes the sea level. This affects coastal communities in Thailand.
My name is Claudia Wieners. I'm an assistant professor at Utrecht University for Earth System Modeling. I live in the Netherlands, and we have one big climate problem, which is sea level rise. Not the whole country, but something like a third is below sea level. Sea level rise is not something that will give us problem tomorrow. It's a slow process. But in the long run, probably a large part of this country is not inhabitable anymore. You know, people have lived in a low-lying part of the Netherlands for 1,000 years, but I'm wondering if they will live here for another 1,000 years.
To address climate change, it will be necessary to slow and ultimately reverse the buildup of human-caused greenhouse gases in the atmosphere. While efforts are underway to decarbonize our economies, progress is slow. With the long-term average temperature of the world now at around 1.3 Celsius above the pre-industrial level, limiting global warming to 1.5 Celsius now seems implausible. In fact, the UN estimates that if countries follow through on their current pledges to cut emissions, the world would be on track for more like 2.6 Celsius of warming. This is the context in which interest in sunlight reflection methods, or SRM, is growing. But what is SRM? Let's turn back to Ping Ping Narenpitak and Claudia Wieners to define it.
SRM, or solar reflecting methods, or solar radiation modification. All of these are a mouthful. They are an approach to pretty much reflect the sunlight back to the space more in order to cool the surface temperature.
The obvious way of controlling climate change is, of course, to stop emitting greenhouse gases. But if that's not enough, maybe we could do additional tricks to cool down the Earth by blocking a bit of sunlight, because sunlight heats the climate. And SRM involves reducing the incoming sunlight by a tiny fraction to cool the Earth additionally.
Research into SRM has grown substantially over recent years, but what brings researchers to studying it, and what were their initial reactions to the idea? First, we hear again from Alfonso Fernandez, and then from a few more researchers about their first impressions and about how these have changed.
I showed up in a meeting years ago and started seeing these posters about cooling the Earth. I was finishing my PhD, I think. And I had read a couple of papers before. And then I saw that was serious. So the first thing was, this is impossible. These people are thinking about this. If we are thinking about this, we're already doomed.
My name is Daniele Visioni. I am an assistant professor at Cornell University in the Department of Earth and Atmospheric Sciences. I had never heard of that before. I thought then that it was an interesting topic, and I definitely got into SRM research thinking that I was going to find a reason why SRM is too dangerous. That's what my initial research was focused on.
I'm Mo Leong Tan, an associate professor from University of Science Malaysia. For me, I think human behavior is very difficult to change. I'm involved in several disaster-related study. In Malaysia, flood is the major disaster. Even during flood, some people might not want to move from their house because the mindset that this flood is just normal. But in reality, so there are some cases that people has passed away because they don't want to evacuate from their home. So that's why I think even though people have high awareness of climate change, it's very difficult to change the behavior. That's why I think we need some kind of technology to help us to solve this issue.
Yes, I'm Dr. Rob Bellamy. I'm a senior lecturer in geography at the University of Manchester. I suppose I kind of felt a level of frustration with the lack of progress on climate change and wondered whether these set of approaches might be able to help in some way. And, given how controversial they could be, I felt it was important that people were studying them and made sure that, we don't go ahead and deploy these in an unconsidered way.
My personal reaction was similar to Daniele Visioni's when I started studying this in 2009. I thought this was a really interesting idea that might have potential, but like many others, I was trying to find the deal-breaking problem with it. However, after several years of trying, I concluded that while these ideas have got risks and side effects, none of the physical risks seem to be deal-breakers to me. That said, the community working on this broadly agrees that the physical risks aren't the biggest concern. Rather, it's the geopolitical and other challenges these ideas raise.
My name is Sandro Attioni. I'm a postdoc at ETH Zurich. My research focuses on stratospheric aerosol injection with solid particles, so on solar radiation modification. The solar radiation modification could potentially help mitigate some of the climate risks, but it is also associated with a lot of side effects, like risks that could occur when doing it. For example, environmental effects would be impacts on the global ozone layer or dynamical feedbacks from local stratospheric heating of the aerosols. These things are not understood very well today. Therefore, we really need to do research and collect evidence to get to this point. And not only on the physical aspects of the whole topic, but also on the societal aspects and ethical aspects. Solar radiation modification would not affect everyone on the globe equally. There are regions which would probably be harmed from solar radiation modifications. Other regions in the world would benefit from doing it. There is also a question of governance. Who decides whether we should do that or not? Who has the power? These are very important questions to me, which needs to be addressed first before we decide whether we should do that or not.
Claudia Wieners and Rob Bellamy also shared insights into the socio-political questions that arise when discussing SRM implementation.
So I had some interesting discussions with a colleague who is an SRM skeptic. We also realized that we agree quite a lot on what are the concerns. So he also understands that we have a big climate problem, and I understand his concerns about, for example, SRM being abused as a rhetorics to postpone serious climate action. And yet, I am much more in favor of pushing for research and potential later development than he is. And I think it's about how you weigh these worries. If you're a climate physicist, you're maybe more likely to lie awake at night and worry about melting ice caps. Sea level is rising, we need to do something, and if the something is a nasty solution, that's maybe still better than not doing it. If you are lying awake at night about nasty political processes and power abuse, then you will be more worried about SRM being used against the interests of poor countries or in favor of arguing for further pollution. So there's no easy solution whether we should pursue SRM or not or how, but we should at least see each other's concerns and not dismiss them.
This comes with, as I say, a whole bunch of risks that we need to be cautious and concerned about. And if we're going to be researching these things and potentially deploying them, then I think it's important that there are people, natural scientists, social scientists, humanities scholars, all looking at this problem and trying to figure out how it could be done in a responsible way. And if it can't be done in a responsible way, then how can we govern it so that we don't do it as well?
One socio-political concern is that SRM will undermine efforts to decarbonize economies. We asked the experts about that concern. Here's Rob Bellamy, Claudia Wieners, and Govindasamy Bala.
I think in the last decade or so, there's been a rising tide of frustration that not enough is being done to tackle the problem. So emissions reductions are going far too slowly. Impacts are starting to mount up, and at some point we'll get to the stage where we'll be reaching things that we can't adapt to. So at this stage, people are starting to consider tackling it by doing something a little bit more unusual.
SRM is somehow it's nasty, right? It's at best a techno fix. It's also not solving the real problem, so it's unsatisfactory. And why on earth have we humans, and in particular political leaders, why on earth have we got ourselves in a situation that we need to consider this mess? On the other hand, it really upsets me if you have people who write letters or whatever and say, SRM is dangerous. Yes, it is dangerous. Of course, it's good to point out these dangers, but you always need to put it into the context of the situation that we are in. So SRM is dangerous, but no SRM is also dangerous.
My name is Govindasamy Bala, but people typically call me just simply Bala. My title is professor at the Indian Institute of Science. So how do we address climate change? The conventional options are mitigation and adaptation. And mitigation is basically both reducing carbon dioxide emissions as well as removing carbon dioxide from the atmosphere and storing it in the ocean and land. But there is a limit to which we could adapt. And mitigation, its impacts could actually take longer time. We might actually see the effects of mitigation over multiple decades. Now, what if there is really a climate emergency? And you really need to cool the climate within a couple of years by, let's say, 1 degree or 2. So is there an option? Actually, this is where solar geoengineering comes in, because once you implement it, it can actually cool the climate system within a matter of 2 or 3 years.
As you can see, SRM is a radical and controversial idea for tackling climate change. So what kind of reactions do researchers get when they explain their work on SRM to friends and family? Let's hear again from Maria Belaya, Mu Liong Tan, and Lily Jia.
Common questions I get from people with no expertise in climate science, but even with expertise, were along the lines of what will be the consequences for my town? What are the consequences for farming, food availability, quality of food? So in Russia, they would ask, so wait, cooling? We have a very long winters. They're concerned about the further cooling. Direct health impact definitely is one of the biggest concerns. So that tells you what likely will be driving international dialogue, local impacts.
Maybe I'm the first one in Malaysia who do this study, and then I tell my colleagues, and then they have no idea on what SRM is. So for my friends or for my family, they don't even know what I'm doing right now. So they only know, okay, I'm studying climate change.
My name is Lily Xia. I'm working at Rutgers University. I'm an assistant research professor here. I do have some conversation with my family, especially with my son. When I talked with him, he was probably 8-9 years old, and I talked with him the research I'm working on. And the way he put SRM, probably people can accept it better, because he said, oh, it's like putting an umbrella for the earth. So it's very cute and feels very safe from his opinion. But he has mixed opinion. 2 years ago, there was a wildfire in Canada, right? And we're living in New Jersey. So all the smokes got transported over east coast of US. And then we have really smoky day, and the PM 2.5, it was over 500, 600. And then my son had very different opinion at that time. He said, is this what you are talking about for sulfate aerosol injection? After we inject all the aerosol there, then it will fall down, then created very smoky and very, very bad air quality and very not pretty sky. I told him, no, that won't be like that. But still, I mean, that's probably the general reaction people will have when you first talk with them. If you talk about, well, just blocking less than 1% sunlight, people will have probably a first reaction like my son got, oh, we are putting an umbrella there. But if they think more about it, we are putting something there, it will fall down, it will get back. Then people probably, if they don't know the magnitude and everything, they started to worry about the air quality and their health. Oh, it's not a simple question anymore.
Most researchers studying SRM are quite ambivalent about it. Some are more hopeful about its potential, and others more concerned, but they generally believe that more research is needed so there can be an informed public debate on this idea. For some final thoughts, let's hear again from Govindasamy Bala, Daniele Visioni, Alfonso Fernandez, Maria Belaya, and Claudia Wieners.
You know, I'm a scientist, right? So I am not at all advocating this. So I'm just researching this. But nevertheless, there should be public discussion, and this research should be open and transparent, because, you know, this is transboundary effects, right? I mean, if one country injects aerosols into the stratosphere, the effects would be felt globally, right? So that everybody on this planet has a stake in this.
Because in the world as it is now, there are normally many sources of information. Scientists normally speak through scientific papers, but they are not aimed at the general public. And so there is a gap for sources of information that are both robust and scientifically good, while also being capable and trusted to speak to the general public.
I'm a firm believer that you need informed decisions. Not everyone knows about this sort of research field. So for me, it's an issue of having the right information that is on the table. I'm not in the position to be obligating my politicians to trust what I do, but I think the best way I can do it is provide the information as accurate as I can get with the techniques we have right now.
My hope is that everyone interested in solar geoengineering would actually be a responsible reader. And by this, I mean evaluate presented evidence, critically read arguments, recognize the context, detect subjective statements, try to avoid confirmation bias, which can be hard. This is when something that is familiar to you conflicts with the reason. But overall, having this trusted source of information would mean that you don't have to be an expert in every field.
Humanity has worked itself into a really nasty corner. Global mean surface temperatures have already increased by 1.2 or so degrees. So we're approaching this supposedly magic 1.5 degrees. Roughly this temperature range is where we start to see really nasty consequences. So we are in a desperate situation. We already pumped so much CO2 in the atmosphere that we already have really a problem. So even if we are now very ambitious, this may not be sufficient to avert climate catastrophe. Now, SRM, if applied properly, could most likely, from all that we know, cool down the Earth significantly in a relatively short time. So SRM is a powerful tool that could influence climate for the better if implemented well, but it could also make things much worse. Given that our climate situation is already bad, it could always be that someone is desperate enough in 10 years or 20 years to say, well, let's just do it as quickly as we can. So in order to make sure in such a situation SRM is applied in a good way and not in a way that doesn't work, we need to know what works and what doesn't work. So that's why I think it's important to research this.
As you've heard, researchers studying SRM do so for a range of different reasons, and they've got quite different views about what SRM might mean for our world. In future episodes, we will explore SRM from every angle, discussing the various challenges, risks, and opportunities that SRM presents, with a wide range of experts in the field. Thanks for listening. This is a new podcast and we're hoping to build our audience, so if you enjoyed it, please do share it on social media or recommend it to a friend. And if you have a question about SRM or just want to find out more, go to our website, srm360.org, and we will try to answer it in a future episode.